Hey there, welcome back to another video. So in this video, we'll be doing some revision on NumPy, Pandas, and statistical libraries. So since we have already done with our data analysis part of our series, now we'll be doing some revision on it. So here is the NumPy, and NumPy is widely used for array making. So if you want to create some arrays based on your data, you can use these NumPy libraries. This is how you can perform NumPy to array making. You just assign a variable. Now I'm giving a. You can put anything here as a variable and make sure this you are using this np.array function. Once you use this np.array, you put your list of elements that you want to build array upon and just print this. So this is our array a and array b, and the type of this data has become numpy n dimensional array because we are using the numpy np.array function. So list is getting converted into an array basically. So this is how we can create an array. Now we can do some whole lot of operations on this array. I'll show you one by one. First, let's move ahead with arithmetic operation. Like if you want to add this array A to array B, you just need A plus B. If you want to subtract array A from array B, you just do some A minus B. Now if you want to do multiplication and division also from this array A to array B, you can do that using A star B and A divided by B as well. Let me just run this, and this is already some subtraction, multiplication, division, and power has been done using same. So arithmetic operations is very easy to perform on NumPy after creating the array. Now we can perform all the statistical things like mean, median, standard deviation, variance, min, max, all can be performed on array. This is the output. Now we can also perform indexing on the array. Like if you want to find the first element of this array A, that would be our 10, since we are using 0th position of A for index. And likewise we can get the last element of the array using reverse indexing. That would be our -1, that is our 50 last element that is coming. And we can also slice through the array using indexing. So we are getting this 3 digits from the array. Now we can also perform some filtering inside the array using filter method using a greater than 25. Now our data contains greater than 25 data, right? That is 30, 40, 50 in our array A. Now we'll be getting the 30, 40, 50 exact. Now we can perform the filtering on even numbers and uneven numbers as well. Now here is the even numbers that we are getting. All the elements in the list are even numbers, so that's why we are getting all the elements from the array. So that's it. You can do some basic filtering inside the array like this. Now we can perform random value generation using random rand and random randint. Now for random rand, np random rand does it gives the random values that are decimal in nature. So I can call this 5 also. So I'll be getting 5 digit of random numbers using random rand. Now I can get the random integer as well that are non-decimal in nature using np random randint from 1 to 100, that is the range. Within this range I can get 5 digit from this random randint function. So that is our 88, 77, 13, 46 and 14. So this is the random number that we can get from the using this function. So whenever you run this, you get new value using this function basically. Now we can also perform some reshaping. If you want to see that np.arrange can perform, it can get all the elements from 1 to 10. That's the np.arrange function for you. See, original C is 1 2 3 4 5 6 7 8 9. Now try to reshape this. Now I'm going to reshape this array into a matrix basically. So for that I'm using c.reshape and creating a 3 by 3 matrix, 3 rows and 3 columns and 3 rows. Exactly, we are getting a matrix using this reshape function in NumPy. Since it is already an array and we are reshaping the array into a matrix using reshape. Now we can perform matrix operation also, like matrix multiplication, matrix inversion and transpose of data as well using NumPy arrays. So this is our matrix X and matrix Y. Now we can perform matrix multiplication transpose, like we are transposing the 2 from 3 to 2 and 2 to 3. Basically 3 is getting in the position of 2 and 2 is getting position of 3. Now we can get the unique value from array. So this array contains many duplicates, right? So in order to get the unique value, you just type np.unique and put your variable inside of it function. And you can also sort the array using np.sort. Use the np.sort and put your array variable inside that function. And let's run this. And we are getting the unique values from this array. And we are getting the sorted array using this np.sort. That is our 1 2 3 4 5. Now we can also create some conditional operation, and we can replace some elements from the array with some new using np.where. So np.where comes as a condition. So I'm specifically telling that if the array A contains an element that is greater than 25, replace that element with 100 in the array of A. So that's what exactly it's doing. This is our previous array, and it's getting the replace of 25 with 100. So we are getting 300 because there is 30, 40, 50. These are all greater than 25. All are getting replaced with 100 in the array of A. That is exactly this. So our ultimate array would be 10, 20, 100, 100, 100. Now we can get the line space as well. Linear space would be giving us the 5 decimal point between 0 to 10. That's what np.line space function does. So this is our output. It is giving me 5 decimal point from 0 to 10. Now we can perform some cumulative population as well. Suppose you want to do some cumulative sum of array A, you just use np.comSum, and if you want to do some cumulative product, you can use np.comProd as well. So it will be giving np.comSum would be giving 10 plus 20 would be 30, 30 plus 30 would be 60, 60 plus 40 would be our 100, and 100 plus 50 would be 150. Same way our cumulative product can be also achieved using NumPy array as well. Now we can perform normalization using z-score as well. So here is the normalized array. Our array, previous array is variable is A. So we are subtracting the mean from each element and dividing that element simultaneously with np standard deviation. So we are getting the mean of an array, and we are subtracting the element from it and dividing that element with standard deviation of the array, total array. So that's how z-score normalization works, and this is our previous array, that is A, and z-score normalization looks like this. So each element getting normalized using this normalized variable. So now we can also perform some correlation metrics. Correlation metrics can be performed using that np.correlation coefficient, and just put two array that you want to do some correlation analysis on it. So since we have created two arrays, that would be our A comma B. Put those array inside this correlation function, correlation coefficient, and let the print do its job. And this is our correlation matrix. So that means all the negative ones are not correlated in nature, and the positive ones has some correlation. So that's it basically for NumPy. I'll be switching into the pandas for now. So we are using this data frame from pandas. Now it contains group, gender, age, score, and result. So age and score contains our integer. Rest of the data are categorical data. Now group contains control and treatment. Gender contains male and female. Result contains pass fail. Okay. Now we are calling the pandas using import pandas pd. We are creating a data frame using pt.dataframe. Now we are gonna do some basic data analysis using head, info, describe, null, group by, and cross tab. Now I'm just going to print this since we have already discussed this on previous multiple videos. So this is a basic analysis is looking like. This is the descriptive statistic. This is the main missing value. There is no missing value. This is the group mean, group by, and this is the cross tab. Now what we can do some t-test analysis on control versus treatment. Now you cannot do just control versus treatment analysis, because this control and treatment are categorical in nature, right? So in order to get the numerical data, we need to do some grouping. So what we can do, we can do some group of control score and treatment score. That's how we can get the data scores based on our categorical grouping. So here is the group, control group and treatment group. So we are grouping control group with score. So that means we are getting all the control score data, and we are also getting the treatment score data basically using groups. So in order to create groups, we are just doing this df group equals to control. Then we are creating a data frame on it and getting the score as well. Now same thing goes for treatment also. We are grouping treatment with score and creating a data frame. Now if I just comment this out and try to see what control scores has. So this is the control scores data. Same way you can get the treatment. Same way you can get the treatment score as well. And we are going to do some t-test on it. So we are calling the SciPy library that we have already installed in my system. From SciPy import stats module. Now this stats module going to do some t-test on the control groups and treatment groups. Now in order to do that, we just going to need t-test comma p-value. So t-test and p-value is highly needed. Make sure this is the format you use and call the t-stats dot t-test independent on control scores and treatment score. So these are our desired data values that we are performing t-test on, control comma treatment score. Now I'm just going to run this. So this is our t statistics and this is our p-value. So this is p-value is lesser than 0.05. That means our data, basically control and treatment, has statistical significance in nature. So we have a statistical significant data here. So this is how you can do t-test on it on control and treatment for whatever condition you have. Just use grouping to get the data you want and do some statistical evaluation using t-test on it. So that's how you can perform t-test on your dataset basically. Now I can show you the ANOVA as well. In generally, it's preferred that ANOVA should contains 3 or more columns. That means 3 or more columns here. But I'm getting ahead with 2 only, so it will be very similar to t-test as well. But you can run 2 columns ANOVA as well. That's not a problem. But in general practice, you need to have three or more than 3 columns to run ANOVA basically. So it will be giving you similar value of t-test. As you can see, that p-value is widely similar to the t-test value that we were getting earlier, which is 5.39. So now we can do some chi-square as well. Now chi-square can be done on categorical dataset like gender and result. For that, I'm going to need a table. In order to do that, I'm going to use PD crossstep for gender and result. Now in order to do chi-square, let me show you the table first, how it looks. So this is the table. It's basically getting the count of pass and fail for female and male gender and pass and fail. So based on this table, we can perform chi-square analysis. Our chi-square analysis can be achieved. So let's see how to do that. This is our chi-square. This is our p-value. This is our degree of freedom. This is our expected table basically, and this is how you can perform stats dot chi-square to contingency and put your table inside this function. So this is how it's look. The p-value is 1, degree of freedom is 1, and accepted frequencies are 1.5, 3.5, 1.5 and 3.5. So since our p-value is far greater than the 0.05, so I would say the chi-square analysis showed that the gender and the result has no significant difference. So that's why the association between the gender and result is not statistically significant because the p-value is greater than the 0.05. So this is how we can perform various tests to derive a particular conclusion whether statistical significance data is there or not. So our chi-square analysis showed that the association between gender and result is there is no significant difference at all. Now you can perform these tests. Now Statsmodel is another library that widely used for statistical analysis. Just use from Statsmodel dot stats dot weighted stats import these tests, and then you can run these tests on it. Now in order to run z-test, you just need z-stat p-value z, then assign z-test the column that you want to run z-test on. Like I want to run on score, right? I want to see that whether the score has any association with value of 50. So basically we are comparing the sample mean with population mean of 50. So I want to see that whether it is has any association or not with our score column with 50 value. So let's just run this, and our p-value is showing lesser than the 0.05. That means our p-value and our dataset has statistical significance. Now we can also check the Pearson correlation between the age and score. We are importing this uh, Pearson correlation from using this stats from SciPy, and we are assigning some correlation value, and this is p underscore core, basically p value, and this is our correlation. That's our core, so in short, and we are assigning stats dot Pearson correlation that we are getting from this stat module, and we are putting the columns that we want to see. Now it is showing 0.79 of correlation and p-value of lesser than 0.05. Our test is showing that it has strong correlation between DF age and DF score. So that's how you can imply your correlation. But now you can change this column. You can change whatever column you want. Make sure that those columns needs to be numeric in nature. Otherwise, there cannot be any calculation, right? So you need numerical data for that for correlation analysis as well. And you can also check the normality using Shapido-Wilk test. Same ways you can use this from SciPy stats and import the stats module from it, and you can do some Shapido analysis on it. So for this I'm using the DF score to check the normality. Now it is giving me greater than p value, so I must say there is no statistically significant data is there for normality test analysis using Shapiro-Wilk test. So this is how you can do multiple statistical analysis using stats of SciPy. So this stats module comes as a very handy module from SciPy to analyze various kinds of statistical tests from the data. That's it guys for this video. I hope you like this and enjoyed this video. I hope you learned some statistical evaluation and analysis from our series. Now we'll be moving ahead with some more machine learning concepts from now on. So see you on next video.